Hello everyone, welcome to another video. In this video we are going to discuss the differences between read-only and frozen collections, okay? They both try to handle the concept of immutability in different ways, okay? And they both have some differences on how they do so, okay? So let's start with a simple scenario, a scenario where you normally would have a collection. Let's say I have a list of ints. Okay, let's call it, I don't know, list. And this list has just a bunch of numbers in here. Say 1, 2, 3, 4, 5. Okay. Sometimes you have this scenario where you have some kind of collection like this one that you want to be of a given type. Let's say a list. You want this to be only read-only for public purposes, but the changing the collection should only be something that is done privately on the class, as an example. Okay. So and both frozen collections and read-only collections allow you, in a sense, to do so in different ways. Okay. So let's start with the example of a read-only collection. Okay. So let's say that I want to create a read-only collection. A read-only collection is a collection that is a wrapper over this list, okay, over as any collection. And that wrapper provides you a set of APIs that are only read-only. You cannot directly modify the underlying base collection, okay? So let's create here an example of a read-only collection. So var read-only list equals list.asReadOnly, okay? So this list exposes a read-only method that will convert, if you see here the type, will convert a type of list which has read-only and write methods to a read-only list, which by the name, of course, we expect that list to be only read-only. So this means that if I come here and do read-only.add, I don't even have, read-only list.add, I don't have it, okay, even though my list has an add method, okay? So this read-only list is a wrapper. It's not actually a new collection, but rather like an envelope over this collection that prevents direct modifications via this wrapper. If you provide this wrapper as an input, it prevents any kind of modifications, okay? So if you're using this on a method and this is a read-only collection, it prevents this, it adds this immutability as well, okay? So as you can see, you don't have any add, any kind of delete method. You don't have anything like this here, okay? But let's do something, okay? Let's just console write line the content of this list, okay? So console write line the content of this read-only list for now, okay? So let's call it read-only list, okay? And this is, let's say like this, plus string.join with the read-only list, okay? So you can effectively see the contents of this list, okay? And now if we run it, you should expect the content of this read-only list to be the same as the parent list, okay? And you will see this here, okay? So our read-only list has the same content as the parent list, okay? But what happens if all of a sudden I add an element to this list, okay? So this was the list, so this is my read-only list, right? So what happens now if I add an element to this list, okay? So list dot add, let's say we add 6, okay? So I told you that this read-only collection, or read-only list in this case, but nevertheless a collection, it cannot directly be modified because it doesn't expose any APIs that allow mutation. But if you do a mutation on the original list, that mutation should be visible also on the read-only collection. Why? Because as I told you before, this read-only collection is a wrapper. Think of it like a blanket over the original list. So if whatever's inside changes, you still can see this change, okay? So if I do this and we add this again, you now see that my read-only list has the updated value of the base list, okay? Even though here, when I first did the printing, it showcased whatever value it was back then, but then once I do the add method, this read-only list gets updated, okay? Which, as I told you before, indicates that if you change the underlying base collection, the read-only collection is also affected, okay? So that's something you have to keep in mind when working with read-only collections. Normally they are used, for example, if you work a lot with DDD and you have your aggregate has any kind of array of something, normally that array is exposed to the outside world as a read-only collection, and it has an underlying private list that is populated from the database and exposed through the outside world like a read-only list, okay? Which means that if your aggregate is retrieved again from the database, you should have this, or if this list changes because any change on the aggregate was made on the code, you should see this change reflected on your read-only collection, okay? Now, let's see the scenario of frozen collections, okay? So let's just change this to read-only before add and read-only after add, okay? So let me add here a frozen list now for frozen list, and I don't want to be to array, but rather to frozen set. Okay, this is the let's say the equivalent of an order or some kind of collection of elements. Okay, and let's see what the content is of this frozen list before add. Okay, let's see, and let me just we can keep this one just for comparison reasons. Okay, and let's see what the content is after it's you add a value to the base list. Okay, and here is after add. Okay, now you would say you would expect some kind of similar behavior, but in reality, that's not what happens, okay? What happens is that the frozen list keeps the same content before and after you add elements to the base collection, okay? So I keep on saying base collection. I hope it was clear that both read-only collections and frozen collections, they require some kind of previous collection, some base collection that they then can branch off from, okay? And as I showed you before, and we can run this again, what happened is that when you have a frozen list, the content when you create this list will not change, even if the underlying base collection changes, okay? And you might be asking yourself, why is this ever useful? Anyways, so one of the reasons, and effectively before I go on that, this is like creating a snapshot, okay? So when you do a frozen or as a two frozen set or two frozen dictionary, in case you're using dictionaries, almost effectively creating a snapshot, okay? You create a snapshot that is immutable, okay? So as I was saying, you might be wondering if this is ever useful and when should you use this? In the case of frozen collections, well, frozen collections, they are interesting because they not only do they prevent actual mutation, so they are actually immutable. As you saw here, I changed the underlying collection, but my frozen collection kept the same. So they actually are immutable. Where in the case of a read-only collection, it's just a wrapper over an API level. Also, if you come here to the frozen list, you don't have an add method, you don't have a remove or a delete, okay? Same like the read-only list, so they both have this API level protection. But in the case of the frozen collections, as I was saying, not only do they prevent, they are really immutable, because even if the base collection changes, they don't change. And they are super useful because they are optimized for reading scenarios, okay? They try to make the read scenarios super useful, because normally you would use a frozen list or frozen collection of any kind if you expect the underlying collection, the base collection, to never change over time, okay? If you are expecting the collection to change over time, as the DDD example I told you about, then probably read-only collection is the best one, okay? But in the case of the frozen collection, it actually provides immutability, and since its expectation is that the underlying collection never changes, it does some optimizations for reading and also memory usage. It tries to put values as together as it can in memory, so that it makes operations much more performant, okay? So you would tend to have better reads with frozen collections than you would have with read-only collections. Just keep in mind that frozen collections are actually a kind of recent feature. Anyways, that hopefully it was clear to you some differences between a read-only collection and a frozen collection, and when to use one or when to use both. But before we go, let me show you a benchmark that tries to compare both of them, okay? So let's comment this code out, okay? Just to have a bit more clarity on what we are doing. And let's create a benchmark class, okay? So public class, let's, in this case, since we used lists before, Now let's use dictionaries, okay? So public class dictionary benchmarks, okay? And let's have 3 data structures, okay? One data structure, which is the base data structure, the baseline, the base data structure. In this case will be a dictionary, okay? Say dictionary. Let's be a dictionary of, let's say, int string or int whatever you're feeling like. Let's put it base dict, okay? Let's put this as null for initialization purposes, okay? Then let me copy this 3 times. So in this case, the second one will be a read-only dictionary. Read-only dictionary, okay? Let's put a read-only dict. Okay, and then you would have a frozen dictionary, okay? Frozen dictionary. Let's put here a frozen dict, okay? Now let's set up our benchmark, okay? So public void setup. Let's not overcomplicate this benchmark testing, okay, or showcasing. And let me put here a global setup, okay. And of course this will not work because I don't have benchmark.net installed yet. So let's add this package. I will do it via the terminal, but you can do it using any GUI, okay. So we can go inside the frozen collections project and do .NET add package benchmark.net, okay. .NET. So that's the name of the package, okay. This package now was added to our project, and now I can come here and just import this from the package itself, okay. Now what we need to do is to set up our base data here. So let's put this one here. So let's just create a simple collection of numbers. Enumerable.range to dictionary. That actually seems okay to me. So just creating a simple 1,000 numbers is okay. I mean, we can go crazy. Let's put 10,000. Okay, 10,000. And let's say that our base dictionary is a new dictionary with this data, and then our read-only dictionary is our base dictionary as read-only, and that our frozen dictionary is our base dictionary to frozen, okay? By doing this, we have the setup necessary for our benchmark. Now let's create the baseline benchmark, so the thing we are going to compare to. So a public string, let's say dictionary lookup, okay, can return like doesn't need to have any key. I'll just return, I don't know, 5,000. Let's see the middle, do a middle search. And let's say this is our baseline benchmark, okay. And then let's do the immutable search, or in this case, immutable lookup, okay. Let's see how this performs, and then I do precisely the same thing with the frozen lookup, okay. So the idea of this benchmark is to actually see where this is faster, okay, and see if indeed we could have some advantages performance-wise of using frozen collections, okay. Now let's just create the class to run our benchmark. I don't need this summary for anything right now. And we can do we can get rid of this and then just import this, okay. So pretty much what I did here was a bit of benchmark code, super simple, and the idea is to compare how efficient or how fast, in this case, a read is from comparing the base case, which is the dictionary lookup, a read-only case with a read-only collection, and then in the frozen case with a frozen collection. Okay. Now let's run this this program in the release mode so that we can have this nice benchmark results. This will take a while to run, and I will come back to the video once it's done. Okay. Well, now we have the results of the benchmark. Okay. And if we go up and we check the results of this benchmark, you will actually see here the dictionary lookup, the read-only lookup, and the frozen dictionary lookup. And you will notice that the average time of reading in the frozen collection is actually a bit faster, about 50%, than the dictionary lookup, the base dictionary lookup, but that the read-only scenario for the read-only collection is a bit higher. So frozen collection, the reads are much faster than the base scenario, in this case, a basic dictionary or base dictionary, and that the read-only collection read times are the biggest of them all. So the fact that the read-only are smaller, that has to do with the fact that these kind of collections are more efficient when it comes to reading, because you already know that you already have the expectation that the underlying data will not change. Therefore, you can have the luxury of creating these optimizations to make your reads perform better. Okay. And so you would have not only that, but some kind of memory optimization so that the reads are performed, let's say, more performant. Okay. And hopefully with this video, you got to learn and see a bit more about read-only and frozen collections, why they can be useful, why they can't, and read-only and frozen, of course. And yeah, thank you for watching, and I'll see you in the next one. Bye.